Welcome to Create Tomorrow with Data and Machine Learning. My name's Glenn Gore and I'm the Director of Solutions Architecture for AWS. And it's my pleasure to be hosting you for today's event. Now, this event will showcase how Amazon and leading global brands from around the world are using data, insights and machine learning models to improve the service they deliver to their customers. We won't be diving deep into technology today. Instead, I have 4 exciting Amazon speakers from Alexa, 2 from Amazon.com and Amazon Robotics who will be focusing on the art of the possible and the business outcomes that can be driven for customers through the application of this exciting technology. Now, I really do believe we are entering a new golden age for artificial intelligence and machine learning by not just putting it in the hands of any developer, but by putting it in the hands of everyone who has a need to innovate on behalf of their customers. So you might be wondering, what is data and machine learning? Well, when I think about machine learning, it's technology that infers patterns and insights from vast amounts of data. And actually, when we think about machine learning, I actually separate it into 2 different aspects of it. There's the training of those machine learning models, and then the inference, which is the application of the model that you've trained to drive outputs for your customers. For example, Alexa, when you ask a question to Amazon Alexa, it's inferring your intent of that question. So artificial intelligence and machine learning are used by customers all around the world to solve big problems. For example, the Thorn organization in the US, they're using artificial intelligence and machine learning to help them track child trafficking, for example. Just in the US, 150,000 escort ads are posted every single day. Now, with that many ads, that can overwhelm resources who are trying to look at what ads are real, which ones may be fake or copies. And so they use machine learning to mine this data. And since 2006, they use a product called Spotlight, which they've developed. They've opened 21,000 cases with local law enforcement, which have identified 18,000 victims, of which 6,000 are children. And that is where machine learning can help deal with vast amounts of information. Another area where machine learning is having a big impact is the area of healthcare and life sciences. Now, it's an unfortunate reality that 1 in 3 of us is going to suffer from cancer in our lifetimes. And one of our customers, Siemens Healthcare, is tackling this head on. Actually, Siemens Healthcare, they look after 800 million lives every year with over 9 billion diagnostics tests looking for cancer. And these diagnostic tests are using high-resolution scans of our bodies looking for cancerous cells. And by using machine learning to detect those cells at an earlier stage means that they can detect cancer earlier, and through using personalized medicine have better treatment plans, which increases the efficiency rates of treatment of cancer. Another area where machine learning is being used is the penultimate sport of Formula One. Now, Formula One are really passionate about their fans and giving them insights into what is happening on the racetrack. Now, they're doing this by combining 65 years of historical data they have about the races, as well as the 20 cars in the race that you're watching, which are fitted with over 120 sensors, measuring over 1,500 data points every second. This is for everything from performance data such as the engines and the drivetrain through to aerodynamic data. And by combining this all together with machine learning, they're able to give us insights like, for example, should the race leader pit this lap, or are they better waiting for the next lap? Or those that are battling in 6th and 7th position, should they overtake on this corner, or is there a better overtaking opportunity in a couple of corners' time? Now, by having these real-time insights and sharing that with us and giving giving statistics around, there's a 67% chance that that overtake could be successful. It's driving better fan engagement through this sport. Now, if you think about how we use machine learning within Amazon Web Services as providing services to you as customers, it's really simple. Think about it as there's three layers. There's an infrastructure and framework layer at the bottom where, for example, if you're a machine learning engineer and you want to work with MXNet, TensorFlow frameworks, you want to get into the details about CPU optimization or GPU optimization, there's a lot of choice down at that bottom stack for you. In the middle layer, which is actually our most popular service, SageMaker, this is a simplified service that allows you to start with, for example, defining your machine learning project in an open source Jupyter notebook, be able to select from a range of different models. Actually, there's a marketplace for SageMaker where different organizations are putting, for example, models that are specific to different vertical industries that you can pick from. Once you've selected that model and algorithm, then I can start training that model and look at how it's performing. I can optimize it, I can tune it. And once I'm happy with that model, well, I can, with one click, deploy that through to production. And that production deployment is going to scale in real time with my needs. And then at the top stack here, if you move up from SageMaker, these are the application services. This is great for people who do not want to understand the technology and what's happening behind the scenes and just want to focus on, for example, I want to build a chatbot. And I want to use services such as Lex and Polly to understand the natural spoken voice and turn that into a conversational context, and then take text that's been outputted by my applications and business rules and turn that back into natural sounding speech. That's incredibly powerful. Now, one of the biggest accelerators for machine learning in the future is going to be the convergence of 5G networking, connected devices or the Internet of Things, and artificial intelligence and machine learning. And the reason why these three coming together is so important is because the biggest benefit that 5G networking brings is it's drastically going to lower the latency of transactions through a mobile network. Actually, it's going to be able to do this sub 10 millisecond latency end to end. Now, why is this so important? Well, if you think about devices today, we might want to be doing machine learning at the edge of your network. You need to put a lot of computational power through CPUs or GPU, and that increases the cost of those devices, but also means they're high powered, which actually limits the possibilities where you could use them around in the environment. With 5G, what we're going to be able to do is separate out the processing requirements and centralize those on AWS, and have those end devices just be really simple capture devices that, for example, could have a camera system and then upload that content directly into AWS where you can process it. Now, by doing that, two things. First of all, we're going to lower the cost of those devices, but more importantly, I think, is that we're going to lower the power requirements of those devices dramatically. This means that, for example, there's lots of situations where we could use battery packs to power devices. Not only use battery packs, but actually have those battery packs power those devices for months, even years on end. And that becomes really important when you think about environments such as agricultural situations, farms, or mine sites, or climate research. For example, you might have devices out in the middle of the ocean, for example. Being able to use low-powered devices that can run off battery power are going to be a really big enabler in these types of environments. And you see this, for example, with our Amazon Go store, where the fusion of computer vision, the Internet of Things with connected devices, and AI/ML is changing the retail experience, where we use those combination of technologies to change the retail experience. As a customer, I can walk into a Go store, and once it identifies me by scanning the QR code on my phone, it's using facial recognition to track me through the Go store, and as I take products off the shelves, it understands what products I've taken and allows me to walk out of that store without having to check out. And that's a fundamentally different consumer experience. Actually, just yesterday I grabbed my lunch and it was 37 seconds because I actually can measure the entire experience. And these are ways that AI/ML can change the experience of consumer behavior. So I want to give you a little bit of context about how we think about innovation at Amazon and actually how that feeds into the growth of Amazon itself. We actually encapsulate this within something we call the Amazon growth flywheel. And it's pretty simple to understand. I'm just going to run you through it really quickly because you're actually going to hear it referenced across all the speakers about their roles and how it contributes to the growth of the business. The way to look at this is we have product selection. Actually, the more selection that our customers have, the better their experience is. And the better their experience is, the more they're going to use the website. And the more they use the website, which is traffic, that's going to attract other sellers who want to sell their products on Amazon. And as they attract more sellers, that's going to drive a better product selection. And that's the flywheel. You can see as we put energy into that flywheel at any one of those 4 steps, it has a direct connection and actually puts energy into the flywheel spinning. And that's really important. Now, while that flywheel spins, you can see there's two things above that. First one is, as it scales, we can lower the cost infrastructure through economies of scale, and then we pass that on to customers as lower prices. And this is where machine learning has a big impact. Machine learning actually helps us at every single step at this flywheel. Everything from, for example, recommendation engines helping our customers find the right product across hundreds of millions of different products, to improving the customer experience by better A/B testing and being able to analyze the results of what is actually happening with the customer interaction of those different services, particularly as we start entering different forms of interaction, from moving beyond just the browser to mobile devices, even voice-enabled services. Or what about traffic? How do we optimize that and improve the speed that you're able to get this information? So I want to share with you the Amazon growth flywheel to set context about how we think about innovation. Because really, the way we think about innovation is how do we delight customers, and the framework is the model of how we measure that. Now, I have 4 speakers from across Amazon who are going to share with you their stories of how they use data and machine learning every day to delight customers in different ways. We're going to start with Manoj Sindhwani, the Vice President of Alexa Speech. He's going to talk to us about how machine learning powers Alexa. We have Jenny Freshwater, Director of the Supply Chain Optimization, about how we use machine learning to do predictive modeling of the hundreds of millions of products that we have, ensuring they're in the right place at the right time, so that you have a customer experience where that product's delivered to you within the time frame that you want. We have Michael Vogelsong, who's a machine learning scientist who works on incredibly fun projects such as searching and recommendation engines, but how he's applying the learnings from those projects into new areas such as robotics. And we're going to end with Tye Brady, the CTO of Amazon Robotics, who has one of the coolest jobs in Amazon. He's looking at the harmony of humans and machines working together to create the workplace of the future. So with that, let's go to our first speaker. Now, I was lucky enough to spend some time with Manoj Sindhwani, Vice President of Alexa Speech, who talked about how artificial intelligence and machine learning are helping Alexa learn every single day. Now, Manoj, you're the Vice President for Alexa Speech. What does that role mean you're doing on a daily basis?
It means I get to work on a lot of fun stuff, solve some really complex problems. We get to work on the wake word, which is the way you wake the Alexa device by saying her name. We get to work on speech recognition, and then we work on text-to-speech, which takes the Alexa responses in text and renders it in a very natural, human-like speed.
So why do we need a wake word on the device?
So the idea here is that this is a far-field device. It's always there. It's very easy to interact, but the way we figure out you want to talk to us is by you using the word Alexa. It's a way to say, Alexa, I want to talk to you.
Does that mean all of the processing of the conversation we're having with Alexa is processed on the device?
We look for the wake word on the device, but once we recognize that Alexa has been spoken and you intend to speak to Alexa, then we set up a connection to the cloud, and you can actually then see a blue light that indicates that now we are streaming audio to the cloud. And until the blue light comes on, everything is being done locally.
So when we're in the smart kitchen here, there's lots of devices. There's fridge, we've got 2 ovens, a dishwasher, show device, smart filter, and a microwave, and a coffee machine. If I do want to interact with Alexa device and say, hey Alexa, turn on the device, how does it understand which device I'm trying to talk to?
So we have what we call ESP. And in ESP, what we try to do is, you may have multiple devices that are within earshot of each other. What that means is that they are going to pick up your audio, and they are going to recognize the word Alexa. So we have an arbitration that happens between all of those devices that heard you speak the word Alexa. And depending on the context, one of them will pick up from then on, and the others will just quietly go down.
Now what about with smart homes? Again, we talked about how Alexa is actually a mix of doing some local processing and then taking that audio and processing it in the cloud using those sophisticated AI models. What happens if I lose my internet connection with a smart home device?
So what we actually launched last year, local voice control, and it comes on those devices that have a built-in hub. When you lose broadband connectivity, the local speech processing gets activated, and that speech processing is not as sophisticated or as complex as the one in the cloud, but it has smarts to recognize smart home commands and other commands that you may want to be able to use when you're offline.
I was an early adopter of the Echo device and loved it, worked really well. I was watching a TV show, one of the actors had an Echo device in the TV show, and they said, Alexa, play some music. Except my device woke up. What are we doing to stop kind of that type of situation occurring where she may be picking up the wake word through TV and media?
So for the ones that we know beforehand, we have a notion of fingerprinting. So what we try to do is we try to get an acoustic print out of the commercial that's going to air.
We need an Alexa dog collar for dogs.
Ordering dog food. Ordering dog
You can
food.
bark all you want, I'm not paying for any more dog food.
Ordering gravy.
And in the device, we have a special piece of code that's constantly looking for a match against that acoustic print. And if that acoustic print match happens, we deem that it's coming from a commercial and we don't wake up the device and it's as if that word was never mentioned. Now, when we don't have that fingerprint, what we do is called dynamic fingerprinting. If you have a comedian talking about Alexa, multiple devices in US are going to hear that, and they're going to hear that within seconds or microseconds or milliseconds of each other. So we're able to recognize that a wide variety of devices are waking up, but they have a very similar acoustic print. And based on that, we will suppress.
The other thing I've noticed Alexa has been doing, she's getting a lot smarter around actually understanding there's different people within the household.
Each one of us have a very distinct way of speaking and certain words that we speak in a certain way.
Alexa, how many teaspoons in a tablespoon?
There are 3 teaspoons in a tablespoon. Alexa, put floor cleaner on our shopping list. Floor cleaner added to your shopping list.
So you can enroll, and when you enroll, we will ask you to speak certain phrases. And with those phrases, we're able to accurately capture your style of speaking, and then we're able to offer personalization purely based on recognizing your voice through a normal interaction.
Manoj, there's a lot of artificial intelligence, machine learning and data that actually powers Alexa. Just talk us through how important is artificial intelligence to the magic that Alexa does?
Every aspect of Alexa is driven by AI and ML. To be able to recognize that you are speaking to the device in all kind of environment requires a lot of data. The quality of the speech recognition is directly proportional to the quality of data we have and the amount of data we have.
It's actually a lot more than just voice, because I know we actually have things like, for example, break glass, which is not a voice-enabled service, but is still an auditory input.
Correct. And the intent there was really that we want to be able to offer value to customers who have Alexa devices, and we took existing Alexa devices and added the capability to detect glass break or smoke detector when you're not in the house. And there was a tweet that one of our customers sent out. They got an alert where we detected a glass break and they were able to call cops and the person was arrested.
We've seen the evolution of the voice understanding has just improved dramatically, even since Alexa was first launched to market. You know, the types of questions she can understand, the context she understands, and we're seeing some new features such as, you know, the context of voice itself, such as whisper coming in.
Whisper came because our TTS technology team had worked on signal processing technique where they could create a whisper voice. And when we heard it, we said, won't it be great if we could actually detect whisper?
Alexa, play a lullaby.
And whispering is different from being able to speak at a low volume. And we're able to recognize that and then whisper back to the customer.
What's for dinner? Alexa, open Domino's.
Hi, welcome to Domino's. Would you like to place an order? What's that an order?
Now, one of the newer devices is actually putting Alexa in cars, and cars are actually quite a difficult environment. There's a lot of background noise, engine noise, traffic noise. As the models were sophisticated enough to deal with that, does that have unintended benefits for the other devices as well?
Yes. Anytime we improve our models with respect to their ability to filter out the different kind of noises, it absolutely helps in other environments as well. And so, you know, when we go into very harsh environments like automotives, we're able to take some of that learning and data from there and improve models for non-auto use cases as well.
Now, what I really like about this first session on Alexa was the insight into how Alexa is always learning and is always getting smarter. It's this feedback mechanism that machine learning and artificial intelligence provides. When you think about how we first deployed Alexa, we didn't really know how people would use it. And it turns out that the evolution of Alexa and innovations such as the whisper and break glass capabilities are based on how customers actually use the devices and when they ask questions and provide feedback. This shows the power of iterative development. Now, our next speaker that we're going to be talking with is Jenny Freshwater, who's Director of Forecasting for Amazon.com. And you know, think about Amazon.com, they've got hundreds of millions of products. They're being served to millions of customers all around the world. And so how do we ensure we have the right products in the right locations at the right times. Well, Jenny's going to share a little bit of insights about how they use artificial intelligence and machine learning to do smart forecasting and predictive analysis to ensure that they can deliver those products to customers as they're needed.
My name is Jenny Freshwater, and I'm the Director of Forecasting and Capacity Planning for Amazon's consumer business. Amazon had to invent around the supply chain. It is impossible to have a traditional by-hand supply chain when you're talking about hundreds of millions of products at a worldwide scale across all of the countries in which we operate. One of the things that makes us different is we have automated systems and models that work together in a symphony to go from forecasting the start of the supply chain. We have to produce a demand forecast to know how much product people across the globe want to purchase between now and a year from now. Then the buying systems need to be able to consume that forecast in an automated way for hundreds of millions of products, to be able to decide how much to buy based on how much we have in stock versus what that future customer demand may look like. We have automation around ensuring what we have in our fulfillment centers is healthy. We are automating decisions around placement of that inventory so that when we've purchased inventory from suppliers and it shows up at Amazon, we put it in the right fulfillment centers such that we have products close to customers that they want to buy so that we can then give a fast promise to our customers. Again, another automated part of the supply chain, when you'll get the product, when it'll be at your doorstep. And then, of course, the automation through the fulfillment process and then through our transportation network to your door. So at the core of what my team does is we predict what our customers are going to want. We predict for every single product that we sell on Amazon, as well as for the products that are sold through Fulfilled by Amazon worldwide across all of the locations in which we do business. And we make a prediction for every product for every week for the next 52 weeks. The data is at the core of everything we do. If we don't have the proper data coming into the models, if we're not modeling our customer data correctly, we're going to get an incorrect result. It's getting the right inputs and knowing the appropriate success criteria by which to optimize for that are really the key of building these machine learning algorithms. One of the most difficult types of items to predict really is fashion. You have not only the product, but you have all of the color variations, size variations, and many products that may look the same to a machine learning algorithm, but may be very different to a consumer. For example, black dresses. They may look very similar to our algorithms, but if one were worn by a celebrity, it would obviously have higher demand. This is why we use thousands of attributes in our models. Forecasting for dresses, we would use completely different attributes than if we were forecasting for a book, right? The binding of a dress doesn't make sense, whereas the sleeve length of a book is not relevant. So our models take in rich data, we figure out which of those attributes is the most predictive, and then that is then used to make the forecast for that individual product. My team has a close relationship with AWS. Not only is all of the hardware in which we operate our forecasting models based on AWS, all of our data storage is in AWS, all of our analytical environments are in AWS. One of the things that's been game-changing for us as we've moved to AWS is when you forecast, you obviously need a production forecast, a forecast that's used by all of the other systems that consume. Maybe equally or more important is your experimentation. We need to be able to experiment with new data, with new models, and this has been, AWS has been instrumental for us, because in a production forecast, it's running all of the time, 24/7, but with experimentation, it's much more elastic. You may do heavy experiments 24/7 for 2 weeks, and then do nothing for the next 2. So this has been a place where we've used AWS technologies to our benefit. The biggest innovation that we've had in our space has always come bottoms up. Somebody has an idea, and at Amazon, it's as common for a brand new college hire to have an idea as it is someone at the top of leadership chain. But as a leader, one of the pieces of being right a lot is actually not coming up with all the ideas myself, but listening to the good ones from the team and making sure that they get the space and the autonomy to go and experiment to see if that idea actually has legs and can turn into something big for the business. All of us are thinking big, and so it's only natural that most of the ideas in terms of numbers are actually coming from the people doing the work. I love coming to work and knowing that there's no handbook I can look at to know how to solve today's problems. We have to innovate to be able to solve the problems for our customers for tomorrow, today, and as long as I've been at Amazon across all 9 years, there's never been a day where the problems are boring, easy, or not challenging, and that's what gets me up every morning.
What I really like about Jenny's story is actually how she talks about the complexity that different products have. I would never have thought personally that fashion actually needs a completely different set of attributes around complexity of colour, the sleeve lengths, for example. And that's new inputs, and that's what drives the constant experimentation of the machine learning models and the testing and the iterations, and how do we optimize those models, test them with the customers in terms of are they having a better experience through the website, and if so, then promote that through to production. That's really key to the end-to-end success of machine learning, is that constant ability to experiment. The other thing I really liked about what Jenny was saying was it's not about just top-down innovation. It's not leaders sitting within the business saying here's what machine learning should be doing. It's actually the power of involving all of the staff who are interacting with different services and customers in different ways, and it's their individual ideas and being able to harness those and turn those into new experiments that allow us to use machine learning in new ways to ultimately drive a better customer experience. Now our next speaker is Michael Vogelsong, who's a machine learning scientist here at Amazon. Now at Amazon, we actually think about ourselves as we're a culture of builders, and we hire builders to build amazing things on behalf of our customers. And Michael is one of our smartest engineers and scientists within Amazon. He's actually built services that's used every single day by customers. He's super passionate about the power of search, recommendation engines, and how to apply them in actually different scenarios. Michael's going to talk through his experiences of being a machine learning scientist at Amazon.
I'm Mike Vogelsong, and I am a senior machine learning scientist at Amazon.com, so on the retail side of the business. A machine learning scientist in Amazon can be a lot of things, and really in my journey across Amazon, I've dabbled in a lot of different areas. The real idea behind being a machine learning scientist is saying we have these customer problems that we see. For example, one of the things that we work a lot in is search and helping people find the right products from a big selection. So when you're on the website, how do you find what you're looking for? And behind that is a challenge of being able to sift through that data, understand it well, and deliver those best results. What we try and use is machine learning. We try and build models that take some of that data, make sense of it, and be able to produce results for our customers that they'll like. And it turns out that a lot of these machine learning ideas of how can you associate inputs with outputs actually generalizes to things that we see on the website. So going back to the case of how do you make the search experience on Amazon.com better, people want it to be fast. They also want it to return the most relevant results. So in order to do that, we actually have lots of historical data on what people were searching and what they were ultimately end up buying and liking and rating highly. So again, using machine learning, what you try and do is find associations between what terms people are searching. Maybe they were searching in different ways. Maybe they were misspelling things. And when you have large sets of that data, you can start finding patterns on maybe these misspellings actually meant something else. Or maybe people express what they're looking for in different ways. Some people might look for healthy snacks. Another person might say, I'm looking for organic bread. And to be able to understand, have a machine, have a computer and a server on the back end, understand that those things actually refer to similar products, that's a great use case for machine learning and being able to find those relationships. You can actually extend some of that work to then go to a slightly different customer experience, which is recommendations on Amazon. So when you're on a product page, sometimes we think we can find similar products that you might also be interested in. It may be comparison shopping. You might have a main product and it has certain features, but there are other products that, kind of offer similar attributes. They do similar things for the customer, but they might have, lower prices, or they may have better sizes for what the customer is looking at. To be able to discover what are those products that you recommend in that case, again, is actually very similar to the use case of search. So those two areas, what we tried to do is optimize that, make them more relevant, and we do that with machine learning. I think a lot of times we think about the automation of machine learning or taking things away. I think there are certain ways we can actually use machine learning that actually augments what humans are already doing. We've actually launched kind of a new experience that allows people to see kind of in style categories where it might not be easy to pinpoint exactly what you're looking for with words, to be able to look onto the site and say, I kind of like this style, or examples of this style, but I don't like this. And what we'll do is we'll actually take those and we'll see those preferences of, I thumbs up like this, or thumbs down, I don't like this. We can actually use those pieces of information as labels, what we like to call it in machine learning. With those labels, we can build models to hopefully, given kind of past experiences that customers have gone through, how do we build a system that more faithfully aligns with what people liked versus didn't like. Those labels really inform how the model gets better. Another cool thing that's a little bit in a different domain is actually we've done some work in robotics. And so robotics in the fulfillment centers, or some people, they're basically the warehouses from which we deliver our products. We deal with a huge variety of products. Big things, small things, things with shiny packaging, things with really nice box-like properties, things that, have really weird shapes. There's just all this variety. So when we're trying to do this at immense scale, there are certain areas where we think robotics can come in and help make that process more efficient. And so really in the robotics world, the question is, can we develop these robotic systems that can handle a lot of that product diversity and be able to kind of sort it to different areas or move it through the fulfillment centers in the most efficient way? I think one of the big things that I think has really become apparent with cloud computing being so available is you don't actually need to be a complete expert in machine learning to be able to get some of the benefits from it. I think what we're seeing is with all of these AWS services that help build up machine learning, we're not reinventing the wheel every time we have a new problem that we're looking at. And so I think for a lot of companies that have engineering teams that are maybe more traditionally focused on traditional software development, they're wondering, I see this machine learning, I'd love to have my workforce kind of be able to pick up those things and deliver for our customers. What I see is we're starting to really have all these tools available where you don't actually need entirely new training to get this machine learning up and running. There's so many services like AWS SageMaker and a lot of the related services off of that allow you to really start from a lot higher level than I was able to start with. So I think that's really one of the main areas I see is engineering teams really being able to embrace machine learning without having to go through a lot of traditional scientific training. It's really great when you can have your best workers thinking about the problem instead of the code.
Now, what I really love about Michael's story is actually how he's able to apply his skills and expertise across different domains. He's applied it to search, to recommendation, but then a switch across to robotics. And that's actually really important when it comes to the field of innovation. Actually, as I work with customers all around the world, a pattern I see of customers who are consistently being successful in being innovative is actually they have the same pattern. Their staff are able to move from project to project, and they don't really constrain what they can and can't work on. It's all about this diversity of thought and opinions that come in and the expertise that they bring to different projects. They bring a unique insight in terms of how they could solve that problem. And that's really what the power of innovation is as they go through with that. So another area that's innovating really heavily at the moment is robotics. Now robotics makes heavy use of machine learning. For example, reinforcement learning to help us control robotic arms through to computer vision which allows robots to see. For example, imagine in Amazon Fresh you decide to order some strawberries online. We want to make sure you're getting the freshest, best quality strawberries. So computer vision combined with artificial intelligence machine learning can learn what does a good fresh strawberry look like and only send those best ones to. Now Tye Brady, who's the CTO of Amazon Robotics, he works with these robots within Amazon on a daily basis. He actually has one of the coolest jobs within Amazon. And he's always looking at the intersection of how humans, robots, data and machine learning all work together to do things that are actually almost like science fiction.
My name is Tye Brady. I'm the Chief Technologist at Amazon Robotics. In my role, I get to shape and transition technology for the benefit of our employees and most importantly for our customers. And it is an amazing job. Not only do we get to think about what is in robotics, but what can be in robotics. I believe that work in the future is work that is done collaboratively by both humans and machines. The way I think about this is as a systems engineer, is that humans are good at some things like problem solving, abstraction, and creative thinking, and just using common sense. And our machines are really good at crunching numbers and accessing databases, moving with precision, lifting heavy objects. And if you blend these two things together, you achieve something better. You create this magic of humans and machines working together to do things that the world hasn't seen. There's lots of evidence over the last 90 years of U.S. history that shows that when we add technology, we create more jobs. Looking back over the 90 years, we see that technology innovation seems to have a positive relationship supporting both our GDP and low unemployment. The past 90 years have seen some amazing technology advances. For example, the first ever commercial flight, the introduction of the internet, mainstream computing, the launch of robotics. We see that as we advance technologies, we use machines to do more things, which makes us more productive. More productivity equates to more jobs. And we see this growth inside of Amazon. Since we first invested heavily in robotics in 2012, we've been able to pilot even more technologies with the goal of increasing safety, speeding up delivery times, and adding efficiencies within our own network. With those efficiency savings, we're able to reinvest in new services for the customers that lead to the creation of new jobs. There are also some brand new jobs that have been born out of technology advances. For example, an app developer, or a blockchain architect, or a social media coordinator. These are jobs that we couldn't have imagined 5 or 10 years ago. But as technology advances, we actually create new jobs. Amazon is customer obsessed, and we will go to great lengths for our customer. The Amazon Flywheel, created by our founder and CEO, Jeff Bezos, shows how you can delight customers by providing the right product selection at the right time at a low cost. The thinking is that when you delight customers, you earn the right to create revenue, which helps you reinvest to delight customers further. I created the Amazon Robotics Flywheel to try to explain how I view the investment in robotics and accelerating the flywheel by creating more jobs and, of course, more value and selection for our customers. In my flywheel, the better robots are those that are collaborative. When you add machines that extend human capability to the flywheel, you gain more productivity, which then has more value for your customer. This creates customer delight. When you have customer delight, this creates revenue that gives you the ability to invest both in jobs and technology. It is critical to have investments in both people and technology. There are some great examples inside of Amazon where we extend human capability and bring this collaboration to life. When the customer clicks the Buy Now button, magic happens. It's a symphony of humans and machines working together so that you can get the right good at the right time delivered to your door. Looking at this video here, there's a large, just a huge building, more than 1.25 million square feet in this particular building, where we have humans and machines working together in order to bring the right good at the right time such that it can be picked and placed into your box. So those little orange robots that you see in the bottom of the video they work using AI in order to plan their most efficient route and bring the right pod at the right time to an associate who will then pick out the good and place that into a box to be packed out. So the robotics and automation that we add inside our fulfillment center is really cool and amazing by itself, but it actually helps us tremendously in fulfilling our customer orders. We have a larger selection of goods thanks to our robotic systems. The robotic systems that we have inside the fulfillment centers allow us to have 40% more goods as compared to manual buildings. This is phenomenal. And the efficiencies that we gain by having the right good at the right time be delivered by the robotic system to our associates allows us to fuel the fast delivery times that we know our customers love. Here's another great example of how we extend human capability in using robotics and AI inside our fulfillment centers. We have what we call a robotic tech vest, and the tech vest our associate can place on their body, and it instantly signals to every robot on the floor where that vest is and allows the drive units, the robots themselves, to replan on the fly around that person. Sometimes things fall off of the pods, and an associate needs to pick that up. Sometimes an associate needs to debug and diagnose what's going on with the robotic system. And the robotic system itself is always busy doing its job of bringing the right good to our universal stations at the right time. But we understand that it's not the robotic system that is making the decisions. It's our associates that are making the decisions. It's our associates that are in charge of the system and understand how the system can work better. So by donning the robotic tech vest, by wearing this vest, it allows them to walk freely anywhere inside the structured field and solve problems. And then the robotic systems will then adjust accordingly. They will change their pace. If it's in the very near proximity of our associate, they will completely stop. If it's in the near proximity, then they'll slow down. If it's in the far proximity, then the robotic systems will actually adjust their routes using our AI systems in order to be as efficient as possible. So I brought a little home video here that shows the technology of the vest working in collaboration with our robots. So here we have one of our engineers, and you can see that the drive units are queued up behind the engineer, and as he decides that he wants to walk towards the end of the floor, we program all these drive units in this particular example to try to get to the other edge of the floor. So it's like a big game of red light, green light type of thing. So he will walk his way down. He's like, you know what, I'm going to change my direction. I'm going to go to the far end of the floor. And you can see that the drives that are closest to him will stop so that the human can do whatever the human deems to do. And then if it's in the medium range, then they'll slow down. If it's in the far range, those drives are actually replanning themselves automatically. And we use our AI systems inside the drives and also the collaborative extension of the vest itself to make the proximity aware to the overall system. Another example where we extend human capability inside our fulfillment centers is the universal station. So here's a picture of one of our associates, and you'll notice that she's holding a bar scanner, which she would use in order to identify each product and making sure that the right product is going into the right bin, and this takes time. So at Amazon, we're really focused on efficiencies and increasing them for our customers, so we created the Universal Station. This video shows one of our test engineers who can now place any object into any bin, and it's scanned on entry. The AI system automatically detects which bin each object has been placed into, making the job more efficient. This new system gives the human more freedom, more choice, and allows us to extend human capability, the cognitive capability of our associates, in order to solve the problem. I believe there are three key ways that robotics helps spin the Amazon flywheel faster and deliver more value for our customer. One, it increases selection. By using the robot drive units on the fulfillment center floor, Amazon can store 40% as many goods as non-robotics-enabled fulfillment centers with the same storage footprint. Two, it lowers cost. The efficiencies that we gain in our FCs allows us to pass on a low cost to our customer, which helps spin this flywheel. And three, it helps Amazon get the right product in the right place at the right time and deliver the customer promise. Robotics does spin the flywheel faster, but our job is never done. I believe that it's still day one for Amazon and most definitely day one for robotics.
So one of the things I really liked about Tye was sharing there is how robotics and humans are working together, and they can have quite big impacts on the business we run. For example, within those fulfillment centers, you can imagine these things are 1 million square feet, and being able to increase the density by 40% through the use of robotics because they can store the racks for goods closer and closer together, that has a big impact, as we shared in the Amazon growth flywheel around, for example, the selection of services that customers have. That's directly attributed to the use of robotics in those fulfillment centres. So as you can see, there's been a lot of sharing of information from our speakers today. But I want to leave you 4 insights from my perspective. And the first of those is the importance of being agile and having high velocity decision making, coupled with the need to experiment to increase that pace of innovation within your organisation. One of the best tools to use this is SageMaker, which allows you to focus on the data and the insights you can drive off that. It allows for a very high pace of experimentation to see what is possible with what you have available to you. While we're talking about what's possible, this brings to the second point, which is the importance of gaining insights. Now, one of the things I really love about companies that first start down this path of machine learning is you're going to be able to ask questions of your data that you've never been able to ask before. And this is going to give you insights that you've never had before. And as you get these new insights, it's actually going to lead you to new questions. And this becomes a nice flywheel in of itself. Whereas you learn more insights and more questions, you're able to dive a lot deeper into this information and the data you have into the patterns of what's happening within your business or the patterns of how your customers are interacting with you. This is really powerful. So with machine learning, these insights don't stop at just generation 1 of what you're asking of the data. Third is operational excellence and strength of AWS itself. Now, when you think about machine learning, you often go through 2 stages. The first stage we've talked a lot about today is the experimentation stage. And there you want to use services and tools that allow you to get to the conclusion of that experiment as quickly as you can. And let's say you've been able to prove that the hypothesis of the insight you're trying to gain is possible. Well, now I want to scale this to production. And when you think about scaling it to production, there's really 3 factors you want to consider. First is the scale of that production workload. Often we're now talking about more data coming in at a faster pace. The second thing we want to focus on is the quality of the results at scale. When I'm pumping through millions of customers, for example, through the inference model that you've created, making sure that's predictable in the way that's answering those results is really important. And then third is I want it to perform under load. And this is where having millions of transactions coming through, for example, every hour, or in some cases even every couple of minutes, becomes really key. And so there's lots of different services available to you on AWS to make sure you get that right selection of capabilities against efficiency, which is important. And then finally, the fourth area is bravery. As you look at these questions you're asking, don't be surprised if people within your organization tell you that the questions you're asking are impossible to answer. Well, just because it was impossible to answer yesterday doesn't mean it's impossible to answer tomorrow with the use of machine learning. And so as you ask these questions, think big, be bold, have a bit of bravery, ask those questions because you never know, they might just be answered. And even if they're not, you're going to learn something along the way that might get you one step closer to that end goal that you're trying to aim for. So it's been an absolute pleasure to share with you some of the inside stories of how we use machine learning and data here at Amazon. And I really look forward to hearing from you as you innovate and use these services within your own organizations. I just love seeing the pace of innovation, not only within Amazon, but just across the entire industry at a global level. I love seeing this. Thank you for joining us.